Alright, this is our first video for one-dimensional motion. We're going to make it easy, well, as easy as we can. In all honesty, it's not that hard as long as you follow along, especially this video. As we continue to build on these ideas, things will become more difficult, and in the end, you'll be like, what the heck happened? But for now, it's really not that hard. So what we're looking at is we're looking at one-dimensional motion as a velocity vector. Here we have velocity. The little arrow here represents a vector. A vector has both magnitude and direction. So our velocity vectors, they want to know how fast we're going and what direction we're traveling as well. First, we have to talk about distance versus displacement. There's a big difference between the two. Distance is the amount of meters that you have traveled in a given amount of time. Your displacement is the difference in your starting point and your ending point. So let's say we start here. Here we have an initial of 0, and we go all the way out to 10, but then we come back to 5. So here, our distance is the total amount of meters that you've traveled. Would have been 15 meters. But my displacement would just be 5, because in the end I traveled 10 forward and then 5 back. So plus 10 minus 5 equals just 5 meters. So it's very important to know the distinction between the two. Alright, now we can talk about average velocity. Average velocity is the distance traveled divided by the time. So let's say I start off from 0 again, and I go a total of 20 meters in a time of 4 seconds. So my average velocity, and the average velocity has a solid line over top it. Anytime you see the solid line over top of a variable, that is denoting that they are looking for the average value of that variable. So it's the change in x divided by the change in time. And x is my distance. So from point A to point B, 20 meters divided by 4 seconds equals 5 meters per second. So my average velocity here would be 5 meters per second. Easy. Now we're going to talk about average acceleration. Average acceleration is your final speed minus your initial speed divided by the total time interval. So let's say you're traveling in your car at an initial speed of 30 meters per second, and you slow down to 20 meters per second, and you do all of this in, let's say, 10 seconds. So it's your final 20 meters per second minus your initial of 30 meters per second divided by your total time interval. Now here's where units start to play a very important role. Here we have meters per second divided by second. So our average acceleration is going to be measured in meters per second squared. That means it's a rate of a rate. We'll get more into that later on as time goes. But right now, it's really important that we look at the final speed first before the initial speed. So that way we get our positive and negative values correct. So we notice that we're starting at a higher speed and slowing down. So that means our acceleration should be a negative value. We have to think about these things in our head as we're going through and solving the problem in order that the values that we're getting are making sense with the word problems and the ideas that were given to us in the problem to begin with. So here we wind up with negative 10 divided by 10 meters per second over seconds. So our answer is negative 1 meters per second squared in the end. So that's how you solve for average acceleration. So for our first day, I would say that is pretty good.